I'm Joyce Hornady. You might say accuracy is my business. I make bullets.
You are listening to the Hornady Podcast.
Thanks for joining us and enjoy the show.
Hello, everybody. Thanks for tuning into the Hornady Podcast. I'm your host, Seth Swerzik, and today, a full table to my left, Assistant Director of Engineering, Joe Thielen. He's sitting across from Senior Ballistician Jayden Quinlan, and we're joined today by former Senior Ballistic Scientist and industry legend, I'll say, Dave Emary. Dave, thanks for coming on the show, and guys, thanks for joining us.
Thanks, Seth.
Good to be here, guys.
We need one of those like applause, things. And so, like when Dave,
Judd behind the scenes here, get us, maybe an applause button, like on the radio.
like,
the guy sitting on the radio.
They all clap and cheer.
Where'd you find that old fart at?
Well, the reason I got you guys gathered today, we've got a series of products that permanently changed the scape of not just Hornady manufacturing, but really as a small cal industry as a whole for commercial, recreational shooters and hunters. It really changed things permanently, and it made a monumental shift, I think, in what was possible with bullet, projectile, and design. And what I'm talking about is our ELD-X, ELD Match, and the heat shield tip. And those three things all kind of happened not simultaneously, but really close together. And there was a Doppler radar that was a new purchase or newer purchase at the time, and that really propagated a huge amount of testing and development and research. And it led to product developments that, like I said, have permanently changed what Hornady is in the industry. And that products group really came from you three. And
we got to give a big shout out though to Ryan Damon. I mean, he's gone training now, and that man was instrumental in the tooling, building, design, the manufacturing of those projectiles. So we got to give
And Ryan's been on the podcast quite a bit, so the avid listeners will know
who he.
Ryan turned our ideas and concepts into hardware.
So
that's a huge part of that.
We got to give a shout out to him. I know he's gone on some training now, but
a big shout out to Ryan, like Dave just said, turned the idea into hardware. And it's one thing to have some tools and dies and punches made and everything. Okay, you got a bullet that comes out looking like you want it, but now that machine has to sing. It has to run uncontrollable at 1 or 2 strokes a second, making bullets that are consistent and efficient. And he really set those things up. And now, you go out into J-Cell or something like that and see these bullets making, like I said, 40 to 70 strokes a minute making bullets up and down. And he did a good job with that.
I think this was the project where a lot of things really came together for Ryan, and where he really cut his teeth and established himself as a pretty premier guy when it came to bullet designing and manufacturing.
I would second that.
Well, before we get to the mass production of these awesome products, we have to go back in time a little bit. So let's set the stage here. I believe, if I'm not mistaken, it was around the 2013-14 time frame when this kind of kicked off as like a, hey, we need to get involved here.
Yeah,
I think we got the radar in late 13, early 14.
Yeah, I think it was 14.
Yep.
But we were dabbling with it before we got the radar
from a bullet design.
Yep.
Well, and I think what was kind of going on in the industry was there was a shift where technology was starting to advance with laser range finding capability and rifle performance, custom rifle availability, optics, good turrets. And we were seeing a larger and growing group of hunters start to push the envelope of what was traditional range shooting.
What was the group in Wyoming? It was where Aaron and Gunworks came out of. They were the ones that really started.
Oh, Best of the West?
Best of the West was really the guys that started the legitimate attempts at non-traditional hunting ranges. And then Gunworks kind of came off of that, and Aaron really started pushing it pretty hard on that.
Mm-hmm.
And then you had...
Then there was a bunch of other little
ones, and then you had a couple of bullet companies that were trying to say, oh, we have long-range bullets, and it's like,
Yeah.
Not really. I mean, maybe accuracy standpoint, but not terminal performance.
Yes.
Terminal performance is an often misunderstood metric, even within the industry. And so that was happening. And at that same time, you had, like you mentioned, Ryan Damon, you had Joe, Mitch, Jayden, and Dave, you guys having conversations. How can we make a bullet that's going to better perform for hunting at those non-traditional distances and still provide the accuracy? And then at the same time, as I understand it, Jason Hornady was on a hunt and someone was using one of these bullet brands that touted it as a long-range hunting bullet, and he had witnessed a couple of, from what I understand, bullet failures where they made good shots where you want them, and the bullet just failed to perform terminally. And he kind of came back and said, "Hey, we need.
You guys need to work on this.
Yeah. Whether we like it or not, whether we agree with it or not, is inconsequential. It's happening, and let's give them the right tool for the job."
I think that was the event that legitimized our dabblings at that point in time and turned it into something from mental exercises and thinking about this and talking about it that, hey, this needs to be a project. Let's go.
Yeah, let's actually,
Yeah.
All right, so you guys get the stamp of approval. I need you to make me the perfect bullet. You need to make a bullet that's match accurate and has terminal performance at non-traditional ranges, at those extended ranges. So what did that early design look like for that type of bullet? Because I think a few people misunderstand that the ELD Match was kind of our first bullet in that line, but actually the ELD-X was the purpose. That's what we were doing.
Because we already had the AMAXs at the time, which are your match bullets.
Yeah,
but we knew you guys had already shot plenty of those. We all had that. They were not effective terminally. They weren't good enough.
They
weren't
consistent
designed for that.
They were too fragile a bullet.
Correct.
Yep.
So you guys get the approval. You start working on the project. What did the initial bullets look like? How did that testing go? And then walk us through the use of the radar and discovery that led to the heat shield tip.
Well, you kind of had a line in the sand, which was your existing hunting bullets, your Spire Points, your SSTs, your GMXs, and wherever those stopped working, we needed to extend that from a range perspective. Essentially, velocity based is how it works. But kind of the first attempt was to take those existing designs and see if we could get them to perform at lower velocities, and that wasn't going to work. So it was essentially a ground up, a whole new bullet design. And from what I remember, you guys correct me if I'm wrong, but we had bullets that were expanding at velocities that were very, very low. Like we were blown away. We could get those things to open up at such low impact velocity.
What I think what I remember is we basically laid out a design philosophy first, and we knew that existing bullets we had did not have the aerodynamics to do what we needed to do to get extended range out of them. And we said, look, the first thing we got to do is quantify what does the external shape of these things have to be to get the retained velocities we need to extend the range out here.
Because SSTs had a candler, shorter boat tail.
It was optimize the ogive shape. What's the best possible boat tail length and shit. All that. And that was where the radar started coming in. And then it got to be, what do we do internally now to keep this thing from totally disintegrating at 150 yards, but yet give us a meaningful terminal performance at 700 yards?
Sure.
Yeah. That's a tall order to do both.
It was.
But we had we had FTX, so we had all the data and the knowledge that we knew we can make stuff expand really low. But then those tip shapes didn't give us because remember we put them in a lathe, you drilled holes in bullets, and we inserted tips, and we got that part, but that didn't give us the downrange aerodynamics that we needed. I remember that vividly because we put them soft tips in there, and that did
we
not
put
work.
the soft tips in there.
Worked great terminally, didn't work for other stuff.
Yeah.
And I think from what I remember from the discussions, all of us had suspicions about the tips we were using at the time, because I remember you and me talking specifically saying, I know doggone well at 3,000 foot per second, the stagnation temperatures on these tips is way the heck over the melting point.
Two to three times
higher. And we were doing the 3,200, and you and I went out for one of the very early times, because we made the bullet first. We didn't have the internals yet, but we made the bullet externally and made some of them. And we went out and tested them, And as I remember, we had tested some of them, and we weren't getting the BCs we wanted downrange. And we're like, should be a higher BC than this. And then we pulled up on the radar the drag curve, and I remember saying, hey, Jayden, come here and look at this. And it's like, why is this drag curve
shaped this way?
It's not supposed to do this.
bowing the wrong way.
Yes, that's exactly what it was.
Yeah. And we said, these tips, something mechanical is going on here as this bullet goes downrange in the first, between 200 and 500 yards. And something's going on here because this should not be acting this way.
Mm-hmm.
And then I think, didn't we come back and have somebody in the tool plant make us like a dozen aluminum tips?
That's exactly what we did.
And then I think, if I remember, we put them in, maybe we just replaced the tips and we came back, it's like, oh,
there's the problem.
Okay.
Yeah. We narrowed in on that pretty quick.
Yep.
But yeah, that's exactly what we did. They turned, I don't know if it was white, whatever. They turned us a few of those metal tips out and put them in there. Because we pulled the other ones out and just stuck them in there.
Yeah, I remember that now.
And that really started the race to finding a material that would solve that, that would act like the aluminum did.
Yep, that turned into a, what do you use that'll give us what we need, and is it affordable?
Yeah.
Because there were more exotic plastics than what we used, but it was like, holy cow, these are getting expensive.
Yeah, it had to be economical, it had to be still easy to manufacture, it had to be consistent, and had to have that higher melt point.
Yep.
So now I'm sure you're like, man, where are we going with this? But it was all of that stuff was literally crammed in those few years. ELD-X, ELD Match, heat shield. They all culminated at the same time.
Well, from what I remember of the story, and I was completely uninvolved, but I remember in September of 2014, I knew you guys were working on a big project, and Jayden and I were running the Sniper Adventure Challenge in Wyoming, and we were on some long death march through the Wyoming prairie and going to our next checkpoint, and this is what we were talking about. And I remember him like explaining that you guys had a bullet that you thought was it, like we're ready to go, and you're never going to believe this, but the tips are absolutely deforming in flight, and we got to go back to the drawing board and figure this out.
Yeah, because I think we were at the point of marketing launch when we did that trip. We were getting the BC numbers for launch.
We were down to like a month before they were going to announce new products, and we went into Steve's office and said, "Hey, Steve, we need more time on this."
Do you remember that, Dave? Yeah. I was nervous as a cat.
I was kind of uncomfortable.
Major product launch, and I'm like, we got to go tell them.
Up to that point, you're telling everybody, hey, this thing's great, it's working good, here's the different bullets that are going to be in the line.
Terminal performance was
Everybody's excited, and then all of a sudden we're like, we got to stop.
Yeah, because, and we needed that time because the plastic we came up with, we had to completely redesign all the molds, and it took us 3 to 4 months to come up with the plastic, and then we made a couple of like 2-shot molds. We needed that whole year to get
develop
all of that sorted out.
And we went through 3 or 4 iterations of material between existing stuff that was deforming in flight and what is now heat shield tip. We had a bunch of different materials that we had gone out and tested, and 100%. it was this continuation of, no, that's not there yet. No, that's not there yet. Source something new, until we finally found it.
Wow. Well, you guys did find it. You came with the heat shield tip, and now we talked about the external, the shape drag features with the ogive and the boat tail, and really optimizing everything from the external perspective. So on the inside of the ELD-X, that's something that we've really not done before either. That was a combination of kind of existing technology, but stacked together uniquely. So walk us through the inside of the ELD-X and how that design process worked out.
Well, we decided very, very early on that we did not want to use a bonded bullet because it was very, very difficult. In fact, we never really did see a bonded bullet that gave the accuracy that we needed. So we
said, this day.
Yeah, look.
And that's because of the heating process used to bond the bullet, you think? Or the lead displacement?
You got to have really thick jackets to get terminal performance out of bonded bullets, and you can't control the concentricity well enough.
And then you heat them up and melt them, and I don't know how those things obturate in the barrel. They're soft. They just do not seem to work as well.
So you knew it was going to be a traditional cup and core.
Drawn jacket bullet, and I think, if I remember right, after some initial testing, we basically said, the design philosophy here is, this is not going to be a perfect high retention weight bullet at shorter ranges, but if we can make a jacket to, basically continually expand but not give up the ghost at high velocities and give you at least a core of 50 or 60% to penetrate, it's going to do anything you need it to do.
Mm-hmm.
And then we defer a little bit towards trying to get the more classic bullet expansion at that longer distances.
Yeah, kind of 400 plus yards when that velocity's bled off a little bit.
So as I remember, the traditional interlock was pretty low in the bullet, and we went with I think we decided that fairly early on. We went with a really heavy shank and put the interlock up real high.
We did.
Mm-hmm.
And that kind of somewhat came from the critical duty bullets.
Yeah, exactly where that came from.
That philosophy came from that, where, hey, you can kind of make things stop and maybe even
like a shear point.
Stuff break off here. You know, it's a pre-stressed point, and you can hang on to this bottom half of the bullet.
Yeah, that's exactly what it was.
Yeah,
that was
that interlock, kind of an existing technology that we've been using for a very long time, and it's you can think of it, as the listener who might not be familiar with it, as a ring inside the bullet that simply squeezes the lead core. It is gouging into it, mechanically holding the lead with that ring inside the jacket. And that, like you said, it pre-stresses the bullet. The stuff above it can expand and possibly shear off at that point, but you're trying to hold that lead core in there for a longer duration of time as you penetrate. And that technology, traditionally lower in the bullet, you guys moved it up, which...
And I mean way up.
Yeah, way up.
Yeah, it was way up.
2 to 3 times further than we had done it on spire points or conventional SSTs.
And one of the things that I find remarkable about the ELD-X when I look at section bullets and I compare them is the aggressiveness of how that jacket is tapered.
Mm-hmm.
I mean, a normal ELD-X bullet, it is substantially thicker at the base and up through the bearing surface, and then it has a dramatic taper as it comes up into the tip. And that has to be pretty imperative to, one, its accuracy, how well can we draw that jacket, and two, the terminal performance.
That's how you got the downrange. You worked a long time, and I remember the angles on the draw punches with Ryan, and you'd shoot them, and you had faster twist rate barrels, and you'd reduce the velocity to get this, make everything come out right, so we didn't have to shoot gel at longer ranges.
Yeah.
Find the latest shirts, hats, hoodies, and accessories that you see here on the podcast and much more at HornadyGear.com.
I think we should take just a quick detour and talk about that, because we've all seen advertisements from various places where they'll do simulated 800 or 600 yard impacts, and you never know if it's just a downloaded whatever. Talk us through that twist rate correction and how that would implicate the terminal performance.
You guys are all looking at me.
You're the senior ballistician.
So the velocity loss of a bullet is pretty rapid. It might start out at 3,000 feet per second, and by the time it's at 600 yards, it's at 2,000, right? Lost quite a bit of velocity, a third of it. But the spin decay, or the rotational velocity of the bullet, is not lost at really much of a rate at all. It's very, very small. So you may start out at, say, 250,000 RPMs at that 3,000 foot per second muzzle velocity, and at 600 you're doing 225.
Oh, yeah.
So it doesn't really lose a whole lot. So what that means is the bullet is more gyroscopically stable as it travels downrange, because the velocity is being lost, but the spin really isn't very rapidly. So if you're going to simulate a downrange shot, say at 600 yards, you need to simulate not only the impact velocity, but also the spin rate of the bullet, or the gyroscopic stability. So if you're going to do that in a lab in short range, where you download the velocity to what the impact velocity would be, you need to make sure that the twist rate of your barrel is sufficient to produce the equivalent amount of spin the bullet would have when it impacted on the actual 600-yard shot.
What really happens is if you play the game of, I'm going to take a 10 twist 30-06 and slow this thing down to 1,800 foot per second and shoot it in jello, what you've done is you've made the bullet probably a third the stability of what it should be at that distance, and the bullet's going to go in 2 inches and tumble, and you're going to think, oh, hey, man, I got great terminal performance. Well, no, you don't.
Yeah.
When you go out in the field, that bullet is way more stable than that, and it's going to penetrate more like 6 to 9 inches before it tumbles. So it's essentially going to go almost all the way through the animal and not do much to it. And that's when we decided, I think we made up an AR, and we had this ugly old bull barrel 7 twist or 6 twist or something in it. And we were shooting stuff we were matching up based on calculations what the spin rate should be at that velocity, and then that correlated to a distance.
Mm-hmm.
We should probably clear that up too a little bit because Dave touched on it. That was the whole issue a lot of us had was conventional match bullets being shot at these longer ranges, being tested, like you just said,
Right.
with a slower. They go in, they tip over, they yaw stuff. Go, oh yeah, this works great. Then you go use that bullet in the field, and it doesn't it's a
work
day
at all.
and night. It's
Yeah.
a day and night difference,
Yeah.
and we're like, whoa, timeout. You
Yeah.
can't.
Sometimes
You're
it works
deceiving. You're
good.
deceiving the customer. They're not
Yeah.
getting.
Right.
Well, that's another probably another good tangent. So we tested our AMAX early on for terminal performance and found it to be just a little too thin, a little too soft to be used for big game hunting. Walk us through. I know you guys tested it, boat tail hollow point. How does that design work terminally? What did you guys see in your testing there that led you to say, hey, you have to have a tipped bullet?
They don't expand at all.
There's
I
no
mean,
mechanism.
We shot boat tail hollow points at effective, I think, 150-yard impacts, and literally recovered the intact me-plat point of the bullet
nose.
jacket out of the gelatin.
Mhm.
It's like these don't expand;
And
they
then
tumble and break up.
And then at long range, you don't know what they're going to do.
Yeah, you have
we had
no
them hit
idea.
the wall. We had them come out. So
Yeah.
I mean, you don't know
They're
what they're
very
gonna do.
erratic.
Very erratic.
Yeah.
And that's because there's nothing compressing the nose to initiate a consistent type of expansion. They're relying on tumbling,
Yes,
essentially.
Yes, yeah. Essentially, the bullet going end over end. I think we described that in the terminal performance podcast.
Yes.
But that increase in surface area as it goes end over end is
And that's why some people who have shot those style of bullets over the years have witnessed amazingly dramatic bam flop type of kills, and then will have also experienced 10-ring shots that the animal runs off.
If you happen to hit or glance off of a bone, yeah, they tumble and probably work just fine. If you don't, you virtually see no reaction at all to the animal because you've punched a hole the size of a pencil through it.
Yep. So that was the ELD-X and the heat shield tip. And so you've got the polymer tip now that resists that aerodynamic heating that was happening. You have the shape drag of a really high BC match bullet, essentially. And then internally you have the jacket, taper structure, and the interlock ring to hold that thing together. So you get match accuracy, you get close range and traditional range performance, and you get the extended range performance. That really, being tasked with making the perfect bullet seems like an insurmountable task, but seemingly you guys knocked that right out of the park.
And I would think at least what I remember, the design and all that, was taxing. Then we had to go make them, and that was a challenge.
Yeah, that's
was
the
a learning
Ryan Damon
curve.
thing.
Oh,
there.
that was a big learning curve.
What were some of the difficulties that you guys faced early on in getting these things to run smooth?
Well, I know the first thing that really sticks out with the ELD-X to me was we had departed so much from the other cups and materials, the amount of material that you were working, and then in that jacket, just the sheer volume of material to get the interlock and all the stuff in there was very hard to draw a really good concentric jacket.
Yep, that's what I remember too.
I think to me that was one of the hardest.
to our match standards, right?
Well,
Like
that's right,
that was
'cause
the
they
level
were-
of expectation. Like this thing was going to be held to the same level of dispersion as the match bullets did, but your jacket's twice as thick.
Right.
Well, didn't we early on, Dave, when we kind of set all our parameters? I think the number one parameter was on that. We have to hit the target before we can think of anything else. So
Right.
I'm pretty sure
it
ELD-X
has to be accurate.
It has to be accurate.
And I recall, having to do a lot of playing around with the draws and how much we drew when and everything else in order to get the concentricity.
100%.
Wow. Well, I can tell you from shooting them, and I've shot matches with them. I've shot a pile of animals with them. Just returned from a trip, and the terminal performance I've never experienced anything like it. Shot animals at muzzle velocity almost, and animals at some extended ranges with it, and it simply works. I never have to question it. The accuracy's there. The terminal performance is always there.
This is something else that I just remembered, and you guys might remember this too, but you know how it is when Steve wanted to always see physical proof in this whole twist rate thing, and I don't know if I believe you guys with this slowing it down and this, I want to see results from actual distance. We're like, oh, geez, okay, Steve. And I remember we went out to Lexington. We had like this 3 foot by 3 foot pile of gelatin out there at like 700 yards and shot it. And it's like, okay, they work. And go back and Steve says, okay, I just don't know if I believe you guys sometimes.
That's interesting. So you guys get tasked with making the perfect bullet. You design the perfect bullet. You get it to run in production. And one of the things that I've speculated, I don't know if this is true, but as it seems that the weight selection of the bullets was almost just a corollary to how it works. So we're going to take this shape. We have to have this lead layout within the bullet. The jacket has to be this thick. Coincidentally, that bullet weighs 143 grains
100%.
or whatever.
Well, that was all driven by, look, we have to have X retained velocity at this distance.
Mm-hmm.
And, the shape of the bullet is relatively fixed. There's only so much and so far you can go with that. So, okay, the rest of this has got to be weight. So that pretty much decided how long they got to be and what the weight is.
Yep. Awesome. So, and I'd say that I bring that up for our listener to understand that we're focused on the accuracy, the compatibility with twist rates. You talk about bullet weight and bullet length. We're focused on those metrics and the terminal performance, and we're not looking for some, everybody needs a 30 cal 168 grain bullet.
100%.
Yeah, no, we're looking for the performance, not the traditional weights that people get warm and fuzzy about, because I know that was always something that I thought was weird early on, because I was in the tech department taking phone calls, and you would get the guy that would call up right after we launched that bullet, and how are you not going to have a 7mm 168 or a 30 cal 168? It's like, we don't really care what it weighs.
Weight's just
after performance.
Work.
Yep.
Weight is a number.
Utilize your space your way with the modular Hornady Security Square Lock Organizing System. Mount the Square Lock panels anywhere in your home or shop. Then attach the wide assortment of Square Lock accessories to securely store firearms, tools, gear, or any other valuables in any possible configuration. Keep your reloading bench or gun room organized with the Square Lock Modular Organizing System from Hornady Security.
And that was another conversation I remember us getting into with Steve, the 3212. We made that the long ogive because we were saying we got to offer one
We
bullet
have to offer a bullet
for these guys that want to go wildcat and have these huge cartridges and magnum length magazines and all that, and
hand loading component only, that 30 cal 212.
Yeah, convincing
It was at
Steve
the time,
that so this isn't a magazine length bullet. No. Well, what are you going to sell? 10 boxes of those? And it's like, Steve,
I think we've sold 11.
Yeah.
Yeah. And I bought one of those. So
and it took us a whole afternoon to convince Steve that, there's guys out there that are non-traditional, and you got to offer something to these guys.
Yeah. Well,
we could see that's the way it was. I mean, look at
the way it was going.
Hindsight's 2020 now, but you could already see the path was headed that way.
Yeah. And I was going to say, thank you guys for doing that, because what started out life as reloading components only in the 30 cal 212 and the 175 7mm, there are now cartridges designed almost specifically around those bullets with the 300 PRC and the 7mm PRC.
Yeah, 100%.
You take ultimate efficiency, big, heavy for caliber bullets, incredible design features, low drag, terminal performance, and they just flat work.
Yeah.
So shifting gears a little bit from heat shield tip and ELD-X, what was the conversation like? Was it just kind of a natural progression, or was it kind of an aha moment to say, hey, we've got an existing bullet, the AMAX bullet, it's a good bullet. Now we've got this heat shield tip technology that we discovered to use in the ELD-X, to shift that over into the ELD Match, because those two bullets rolled out together as a pair. So was that the purpose goal initially, or is that kind of an additional thing that, hey, these ELD-X bullets came out pretty good, we should pair that into a match bullet as well?
Well, part of that discovery of the tip deformation and stuff that led to heat shield tip was, when does it and when doesn't it occur? Because it doesn't occur all the time.
Right.
And so essentially what we found there was, in very, very simple metrics, if your muzzle velocity was above, I think it was 25 to 2,600 feet per second, and your G1 BC was above 500, those two metrics with a grain of salt, obviously, but generally, if you surpassed either of those two, you would see the tip deformation stuff. So
that's about what I remember.
So when you see it when you see us take a hard look at the AMAX line, the reason the AMAX line was looked at so hard is because many of those bullets had those criteria. They were being shot at muzzle velocities north of 25, 2,600 with BC values north of 500 for a G1.
Mm-hmm.
SST, VMAX, GMX, the other tipped projectiles of that same era, you didn't have those sort of BC numbers, although the velocities were that high. And your velocities may get extremely high, like a 22-250, well north of 3,000 feet per second, right? And you don't see that happening. And that's because those bullets slow down so rapidly that although the temperature is very high, the time exposure to that temperature is low enough that it doesn't have an effect.
Interesting. Okay, so you isolated. All right, this is occurring, and did you guys just plug the existing tips into the new tips into the existing bullets, or was it back to the drawing board for those as well?
It wasn't back to the drawing board. Joe and I and Jayden had gotten in on some of those conversations late, had conversations for years on our existing match bullets that, these things aren't exactly optimum shapes for aerodynamics.
Mm-hmm.
But there was never a real strong impetus to go change that. What got works. Nobody's complaining. Leave them alone. And then after all that ELD-X work and, being able to show people quantifiable numbers of, hey, if we put a better boat tail on this, look at what it does to this thing. And then, the tip thing had already been defined. And it was just, I think, a natural progression of, hey, here's a way with minimal effort on our part to make a very substantial improvement in the downrange performance and aerodynamics of these match bullets.
Mm-hmm. Yeah. Makes sense. So you kept the same jacket, our amp jackets that we're known for. Yeah. Moved some boat tails around, some O-drive profiles around, it looks like.
Yeah. We knew how to build the ELD AMAX/ELD match, we knew how to build those from a jacket standpoint. We had been drawing those and course eating them and all that for years. So that part was relatively easy. It was the shape and the tip and then the testing. You guys probably we kind of touched on it, but we tested, I don't know how many test shots and testing we did between ELD Match and ELD-X, but I know we hunted with ELD-X a lot. Us technical guys went and shot stuff to make double sure that everything worked. Yeah. Same way with the match bullets. Shot a lot of those to ensure that.
The first match I ever shot with those was when you and I went to O'Neill. So
Walker draw.
Yeah, it was our first what became like PRS style stuff. That would have been
like an outlaw match.
It was an outlaw match PRS style. We had never done it, and
no, we were not.
And we were fish out of water. That was wild.
I remember that it was foggy as the dickens driving there. It was, a couple hour drive doing 45, 50 miles an hour. And Jayden and I had just did the Sniper Adventure Challenge, which is a kind of an adventure style, survival race, if you will. Didn't know anything about, I knew the PRS was a thing, but had never shot it and didn't know what that style of shooting was. And man, I had 5-round magazines shooting a 308.
Yeah, I was shooting the prototype 140, which was some of our test bullets that we had at some point there. I shot those at that match. And I remember guys seeing those rounds in my magazine and asking because they looked different.
They were trans. Yeah, at the time, the R&D stuff was translucent.
And so I was trying to kind of hide what I was shooting and only, load my mag when I was up on the firing line and nobody could see me. But
the first stuff we ever did was that amber color, like a honey color.
Yeah.
In the first stuff.
That was the raw.
Yeah, that was the raw stuff. Yeah.
Yeah.
What I remember on the ELD-M bullets was again, and to Steve's credit, because he wants to make sure that what we're advertising as a company is legit. And, we told him all what we were going to get and the benefits of, and hey, these BCs improved this much. And he's like, give me something I can relate to.
Yep.
So I remember going out to Lexington, and I think we were shooting 308s at 600 yards, and we shot the old AMAXs, and we shot the new ELD-Ms.
And we had
we had the
two groups.
We held the same come up, and it was like a 2-minute difference at 600 yards.
They were all loaded the same velocity, same gun, same everything, and you literally just shot them on a big.
We took a picture of the target, and there's a blob up here, and there's a blob down here, and take it back and gave it to Steve, and okay.
Yeah, I remember that.
Well, and those small refinements that you talked about, the boat tail length, the angle, the O-jive, the addition of the heat shield tip, I don't remember the exact numbers, but the 140 AMAX to the 140 ELD match got nearly 100 G1 points of BC.
It was huge.
Yeah. It was a substantial. I want to say the G1 on the 140 AMAX was like 585. and the
I think that's right.
Yeah, 585 and the 140 ELD match is.
Well, it was tip deformation was part of it, and the other part was the old school traditional boat tails. Really
little steep,
little steep. You had flow separation at the rear, and they honestly really didn't do hardly any. It was almost like shooting a flat base bullet, not quite, but almost.
Mm.
So you put a good boat tail on there, and you pick up a ton.
That was fun to learn. Do you remember that, Dave, when we were monkeying with all that stuff? And because I was like, boat tail, whatever. You knew it made a difference. But when they started slowing down at long range and the boat tail kicked in, the front end of your high speed velocity is all ogive, right?
Yeah.
But when that boat tail kicked in and you had different shapes, you're like, wow, that thing just retained 100 more feet out there at 800-900 yards.
And that's the beauty of the Doppler radar. You can see this.
Yeah.
Yeah, because it gives you a data point, every 1 to 2 feet?
If you said it that way.
Yeah. I mean, we didn't know any better. We were basically using the Doppler radar as a pseudo spark range,
Kinda.
We didn't know any better.
I know this is a tangent, but where did we go, now that we have you here, where did we go the first time? Was it New Mexico where we shot on that radar over behind the mountain? And
we went
because
down
that was
to,
my first experience ever.
It was 2011.
With a radar.
It was 2011. We went down to EMRTC and we shot Honeywell's radar because Honeywell's got a permanent range down there. But that was when the Army was saying, we want 1 MOA accuracy at 1,500 meters. And, we're like, the bullets you have, you can't physically do this. So we went down and shot Doppler radar data and made them a report that said, look, this is you can't do this. Not with what you have on the shelf right now.
So it was that early on. Because I just remember after that and coming home and I'm like, Dave, we got to figure out how to convince, man. We got to get one of these. We got to get one of these. This is like...
That's when we started.
Okay.
Yeah, chipping away at it.
I had used a radar back in the 80s, and that's where I knew to go down there, and that was 2011. I remember that now. And, it was...
I was just in awe. I was like, we got to have one of these.
Yeah.
We need this. And Dave's like, I know. I've been saying that for years. I'm like, well, we need one of these.
It's about the cost of your average home back then. Is what it cost.
It was a substantial part of a home back then. Yeah.
But we needed one of those. I just remember we used to tell, I don't remember how the conversations went in the office either, but I know it was finally a few years later. Was it when Jason got more and more involved? Jason, we need one of these. And then he started pushing, Steve, we got to have, why do you need one of those?
That's a lot of money. What am I going to get out of that?
Yeah.
And there was no answer to that question. What are you going to get out of it?
We didn't know we're going to measure
the velocities, but
yeah,
you could do that with a chronograph.
I mean, yeah.
Well, I think we said we can use this to refine bullet designs. Well, what
are you going to change in bullet design?
Yeah.
Well, luckily he saw the light, and the future of the company was permanently changed.
Trajectory changed for sure.
And I think we'd be remiss if we didn't discuss kind of the previous industry standard, and then how we changed what we do. And what that looks like now in regard to ballistic coefficient. I've had people comment on this podcast like, Seth only knows random G1 BCs, but whatever. It's like, we don't talk about BCs internally almost at all anymore. The reason I know some of them is from looking in the load manual or whatever, because we just don't talk that way anymore. But at the time, previous to this, most BCs were measured or calculated at a traditional 200 yards, 300 yards, let's say. Now you have this Doppler radar, and you can really refine the ballistic coefficient even more. And we'll leave the FORDOF and the drag coefficient based trajectory stuff for a different podcast. But what did ballistic coefficient measurements look like prior to this? And then what do we do now with ballistic coefficient? How's the radar involved in that?
Well, the legacy measurement methods were hamstrung by the tools you were using, which was generally chronographs. So you have to be able to shoot the bullet across the chronograph to measure it to calculate the BC.
Real quick, how many...
Do you remember that when you showed me how to do that, how hard that was? We can dive into that too. But
how many chronographs have you guys shot collectively?
Impacted the chronograph?
Yeah.
A few.
I know we blowed up a few screens.
I would never.
But do you remember how hard, Dave, we had to measure it to the inch and then get all...
Yeah.
It was hard to get a really accurate number.
We went through all of that, and it's like, this is one number at one point, and it took us a while to really figure out what all this is and how it means. That it got down to, this is really only good for a point in space and for a relatively short distance. And as you guys remember, at the same time, that was when we really started getting hooked up with the military guys that were like, we want 2,000 yards. And we're like, oh, come on, BCs out there are absolutely useless. Nobody even has any idea what they are.
Yeah.
And,
Correct.
And what you think you're getting for a BC and going to have for holds at 300 yards versus, this is completely useless. There has to be another way to do this. And this leads into Ford off. But
yeah.
Sure.
So before you were, like you said, Jayden, sorry, but I wanted to know how many chronographs you guys have shot over the years, because we're all guilty of it. But anyways, you had to get the bullet through the screen to get a velocity measurement.
Yeah, and so that forces you to do it at ranges where you can achieve that, which are generally shorter ranges. So the industry was really based around publishing BC numbers that were gathered from 1, 2, or 300 yards, because you can reliably get data at those points.
And 300 was a stretch.
300 was a stretch.
And most facilities don't have a 600 or 1,000 yard range that even if you wanted to chance it and try to get a measurement out there and maybe hit a chronograph, you could. So it's not only an instrumentation limitation, but it's a location limitation, and so everything was based around short range stuff.
Yeah. And then, to interject on my own question here, right around that time frame, that's, we talked about the rapid progression of barrel quality, rifle quality, optic quality, laser range finding capability, people using tools that are getting better to shoot further distances. And those 1 and 200 and 300 yard BCs just don't get you on target at 800 yards.
No, you're going to miss.
Yeah. So you tweak it around. And so now with the Doppler radar, now you guys can get better BC values at different ranges. Talk us through, I can talk about the marketing side of it a little bit, but I'm sure you guys can as well, about what's on the box versus, we have some expanded BCs on our website, and how you guys use the radar for that.
Yeah, well, the first BCs we published were an 800 yard average with the radar.
we took an average over 800 yards with the radar.
But the problem there was that so BC changes as a function of velocity, and generally speaking, it goes down.
Okay.
Not all the time, depends on the bullet shape, but in general, it goes down. So what we saw was we publish all these numbers that are based on an 800 yard average BC, which means it's more useful for you using a BC calculator. Your trajectory predictions will be a little bit closer to what actually happens.
Okay, that makes sense.
Versus the 1, 2, or 300 yard number. The problem is those numbers were lower. So a guy goes to a store to buy a box of ammo or a box of bullets to reload, and one of the metrics people use is BC. They're going to pick the one with the higher BC. That's better.
Yep.
And so we saw that people were picking bullets that had a listed higher BC because they were tested at 1 or 200 yards, not that they were actually a superior bullet aerodynamically. And so we went back and said, well, we have to have apples to apples numbers available to the customer to make a comparison. So we started publishing Mach 2.25 based BCs.
Yeah.
But as you said on the website, we have a table, so we publish Mach 2.25, Mach 2, and 1.75 BCs.
Okay.
So if you still want to use BC, you have other.
Yeah, I think the presenting different Mach values or kind of the stepped BCs is a good way to do it for the person who's still using BC. And like I said, we'll leave the Ford off discussion to a whole podcast about Ford off, which we have many of already. And that really is the way and the light and the truth. And, it uses your bullet. But so between heat shield tip, ELD-X, ELD Match, monumental discoveries, monumental products for us. Obviously, the reloading components are one thing, but the factory ammunition, then the quality of the factory ammunition. And we talked about this a little bit in several podcasts where you have factory chambered rifles and factory ammo, precision hunter match ammo specifically. That's a match made in heaven. And you talked about shooting 400 yards used to be a long shot. You can go buy an economical but good quality rifle, say a Ruger American, chambered in 6.5 Creedmoor, and pick up Precision Hunter 143 ELD-X. I'll tell you what, it's going to shoot sub-minute, and it's going to do it at almost any range that you can accurately hold.
Yeah.
It's remarkable what has happened in the industry in levels of in terms of precision.
It was a huge cultural change within Hornady, because it took us a long time to convince Steve, who is a very, very good hunter, but he's a traditional 300-yard hunter. And it took us a long time to convince him that with the progress of scopes, rifles, cartridges, bullets, and all that, what is considered a 200-yard shot to an old school guy is now a 600-yard shot to some guy that shoots constantly and has all this high-tech equipment. And I think when it finally converted him that one time with the Riders, when we took him out there and we had him hitting targets at 700 yards, and he was like, I remember that. Yeah, because I think you were on the spotting scope with him.
Yeah,
and I remember you fighting with him about dial the scope, don't hold over,
and your turrets.
Yeah, I remember that, and that was I think that was a watershed moment for Steve when he really finally started to understand. Boy, there really is something to this.
Yeah,
the
level
of precision is
it's
far
not
beyond.
Not a wing and a prayer, not a hope. You can very confidently lay down and put that bullet exactly where you want it.
Yep.
Awesome.
Hornady Outfitter ammunition is now loaded with Hornady CX bullets. Its optimized monolithic design combined with a heat shield tip offers extended range performance, enhanced accuracy, high weight retention, and deep penetration. Outfitter ammunition features corrosion-resistant nickel-plated cases that are sealed watertight, designed to perform under the toughest conditions. No matter where adventure takes you, trust your hunt to Outfitter ammunition from Hornady.
So I'm going to shift gears one last time. Everybody that's on this podcast, I've already asked you if you had to pick one cartridge, one bullet for the rest of your life. So we're not going to bring that up again. But I do want to know, because you guys were in there at the ground level and you saw all the ELD-X, ELD Match bullets in that initial design, there has to be one bullet that just gives you a warm and fuzzy, whether that be ELD-X or ELD Match. I was just curious, of the two bullet lines, if you had to pick one bullet that really just tickles your fancy, what's your favorite?
You're gonna pick one out of both lines. I don't get one out of each line.
I don't like
if you're gonna pick
these new questions he comes up with.
Yeah,
I don't know.
who gets these?
I'm just curious. Pick one of each. This is
one
just
of
more
each,
for
because if you
for
make
me.
me pick one, I have to do an ELD-X because I can shoot a match with it and I can hunt with it. But if
Well,
you
I'm
let
not
me,
saying for the rest of your life. I'm just wondering, like, what's your favorite? Because I've got one that just makes me feel warm and fuzzy inside, and every time I shoot it, all good things happen. So,
well, why don't you go first then?
Sure. For me, 7mm 180 grain ELD Match. There's just something magical about that in a 7 PRC. It just wind. Never heard of her. Shoot. Hold left edge. It's fine at any range. You can just shoot that bullet at any range. And in my personal 7 PRC, it just puts bullet on top of bullet on top of bullet. And when you lay down on a piece of steel, like I said, it just gives me a warm and fuzzy. And you pick the bullet up to put it in your cartridge case, and it looks like a piece of spaghetti. It's so long. I don't know. I really like that bullet.
Oh, my gosh.
And again, not for the rest of my life or anything. It's just that one. I really, really like that bullet.
Your turn, Joe.
Oh, boy, I'm next. So for me, I had to pick one, it's going to be the 30-212 ELD-X because I had a hunting rifle and a match rifle and 300 PRC before it was even called a 300 PRC.
Mm-hmm.
And when you shoot an elk or a deer or whatever it is with the 212,
piece of steel at 2,000 yards.
Piece of steel don't matter. It knows that you just whacked it with a 212 grain 30 cal bullet. So that'd be mine. I'm partial to that one.
Yeah, big 30s are special.
I'm going to copy you, but for a different reason. So I had a really cool experience with the ELD-X. We went through this whole design process and this whole story we told.
Oh, I know where you're going with this.
And I drew an elk tag back home in Colorado. And it was the first time I had been able to go back and hunt with a mentor of mine that taught me how to, you guys have met Mark.
Yep, shout out to Mark.
And this hunt, I didn't want to be limited. It was my first time paying out of state for a Colorado tag. That hurts a little bit, the pocketbooks, Nope. Anyway, hunting public land, we didn't scout it, had never been there, just, hey, we're going to go do this together. And the hunt progressed just slowly. First day, didn't see anything. Second day, saw some elk on private land. Third day, could hear some cows chirping up in the trees before us, but never saw them. And I had this pull to go to this saddle every evening that overlooked this meadow. For some reason, just had a pull to go there. And I was using a 300 Win Mag that Dave had built, a custom rifle. It weighed about 14 pounds, so it was heavier than you wanted to be carrying around the mountains, but I didn't want to be limited. I wanted me to be the limitation, not my equipment.
You were a younger Jayden.
I was. You
were yoked.
Yeah, back in the day,
Yep.
But that 300 Win Mag consistently shot 4.5-inch groups at 800 yards.
That gun was so pure.
Yep.
It was so good.
And on the last day of the hunt, in the last 15 minutes of shooting light, 2 bulls walked out into that meadow 100 yards from a private fence line, Forest Service to private. And I had trained with that rifle a lot. I knew the capabilities of the bullet. I knew my capabilities. The wind was dead. I couldn't close the gap. It was essentially a cliff in front of me and these two really long fingers that went down and around into some aspen trees. And I had to take that shot. And I will say it was beyond traditional distances. And that bull took 2 steps and fell over dead. And it took us 45 minutes to get to him and, processed him in the middle of the night, freezing cold. Yeah. But if it wasn't for the ELD-X, I would not have had a shot that hunt. I would have had tag soup.
An expensive tag soup.
Yeah. And so that was just a super cool experience for me that was like a complete validation on everything we had done at work.
Yep. And to take that one step further, what you just said is exactly why cartridges like the 300 PRC exist.
Yeah.
You want that level of performance, but you don't want to have a custom match chamber reamer with a custom hand load and all of these custom features. We now provide a turnkey solution that gets that 212 ELD-X to do that type of performance, and that's a good reason to love the 212 ELD-X, the big 30 cal.
And now the drum roll to Dave.
For Dave, yeah.
I would say in terms of a general use, just pick it up and go shoot cartridge. The 6.5 Creedmoor is hard to beat, but I was sitting here after he said that and thinking about it, and I came to the same thing you two did, that, as far as if you were forced to own one rifle and one cartridge and one load, and somebody said, hey, you're going to have to go hunt with this, and you might have to shoot out to a mile with this thing, I would probably go with the 300 PRC with a 212.
Yeah, that ELD-X. 212 is... There is something magical about a big 30.
Just to absolutely devastating effectiveness is that thing as a hunting cartridge, and then to go out there and be ringing a gong at a mile with it. It's just like, what more do you want out of a gun and a cartridge? And I realize there's now probably, I've never shot the 7 PRC, but there's probably more refined cartridges that will even get inside of that. But, that was the first one to me that, boy, this cartridge can do just about anything anybody could ever imagine doing with a shoulder-fired firearm.
Yeah. I love it. Well, we owe a lot to you guys and Ryan Damon and Steve Hornady and Jason Hornady, obviously, for the Doppler radar and then the discovery of the heat shield, the ELD-X and the ELD Match bullets, because I say it and I mean it with the true weight of the words that it permanently changed Hornady as a company. And I think it was really kind of a line in the sand that springboarded us into incredible development, wider popularity, more sales, being way more prominent in the match setting than we've ever been. And it's been a cool ride to watch and to see take place, and now to see our classic white box with the red lettering match ammo features the ELD Match bullet, and our precision hunter with the ELD-X, and how many people. And I get stopped in the airport or whatever that, I shoot your ELD-X, I shoot the precision hunter ammo, I don't have to hand load anymore. This is just amazing. And us as a shooting community, really appreciate the work you guys did on those projects, because like I said, it was a defining moment, certainly I think for our company.
Yep. Yeah, it was fun. Those few years were,
we covered a lot of ground in about 2.5 years.
Yes, we did.
I mean, I would agree with you. I would say that was a watershed moment for the company, because up to that point, we had, the critical duty, critical defense, we had really hit home runs with
Lever Evolution.
We had taken traditional cartridges, and with propellant design, bullet refinement, we had gotten them to about, as far as you're going to go with these things. And the radar, and, we went from propellants, cartridge designs, tweaking bullets, everything else, to just basically saying, look, throw all this stuff out. We're starting from the ground up and building the ultimate in a cartridge, bullet, everything.
Yeah, I would agree.
And I would say it's revolutionized the whole industry.
I'm not going to argue that.
Yeah, you can look out there and see it all over. So that's pretty cool.
Awesome. Well, guys, thanks for discussing that and walking us through. It seems like for me, that wasn't that long ago. And it really, in the grand scheme of things, wasn't that long ago, but it's starting to 2015, think about that, 8 years ago. It's neat that you guys can recollect a lot of those memories, and hopefully you guys didn't forget anything. Any last minute thoughts on ELD-X heat shield tip or ELD Match?
No, other than it was fun. It's been a fun ride.
Oh,
It was a lot of fun.
Still is fun.
Still is
yeah.
fun.
Yeah.
When we get to use it now, it's a lot of fun.
Yeah.
Yeah.
Awesome. Well, guys, thanks for sitting down with me. I really appreciate it.
Yeah, thank you, Seth.
Thanks, Seth.
Guys, hopefully you enjoyed this podcast about the ELD-X, the ELD Match, and the Heat Shield Tip. Revolutionary products. We've used them all over the world. We've shot matches with them. We've hunted with them. Our factory ammunition offerings in Precision Hunter and the Match ammunition have never been the same because of these bullets and this design. We hope you enjoyed it. We'll catch you on the next one.